Okay, ionic compounds. So ionic compounds occur in the Earth's crust as minerals and are also present in foods we eat, interact with them a lot. They have real strong bonds, strong ionic bonds, right, between different types of ions in a crystal lattice. I drew like a two-dimensional version of that lattice before. And then, so ionic compounds always contain positive and negative ions. The first element is usually a metal. The major exception to that is ammonium. So some ionic compounds will have ammonium. There aren't very many polyatomic positive ions, positively charged ions. So in a chemical formula, we'll talk about chemical formula of these, the sum of the charges of the positive ions must equal the sum of the charges of the negative ions. And then for ionic compounds, the formula of an ionic compound is a formula unit. So it's really representing the smallest whole number ratio of the ions in that ionic compound. So 1 to 2, 1 to 1, 1 to 3, 2 to 3, that kind of thing.
Is this kind of like an empirical formula? What's the smallest ratio?
Yeah, you can kind of think of it like an empirical formula, because I think this is another thing that I was pointing out. You could almost think of an entire salt or crystal of salt, sodium chloride, as one molecule, but it's not really a useful definition as a molecule of that size. So we boil it down to that formula unit because that's more useful. Yeah. Yeah, ratios. All right, so they're slightly different. So when we write formulas for ionic compounds, write the symbol of the metal cation with its charge, followed by the symbol of the nonmetal with its charge. And this is mostly, you get kind of used to this, but when you're starting out, it helps to write out both ions with their charges first, then to figure out how you adjust subscripts on each cation and anion to balance the overall charge. So you check that the sum of the charges after you've adjusted your subscripts. Check that those charges of the cations equals the sum of the charges of the anions. All right, so first one on the worksheet. We have the compound formed between potassium and sulfur. Right, so what's the symbol for potassium? Okay. And the charge? 1+. I don't know if I made an announcement about this, but I did post, it's the same ion list that I used for Chem 20, but it's all of the ions that only form a single type of charge. That's posted on Canvas in the week 4, like the end of the week 4 stuff. There's also a list of polyatomic ions there also, so like oxyanions. So potassium's on that list. What about sulfur? Yeah, symbol S, charge 2-. So if we want to balance these charges, how many potassiums do we need and how many sulfurs do we need? Yeah, so it'll be K2S. So one of the other ways that you can do this is called the crisscross method. There are some places where you have to be careful with the crisscross method because things need to be simplified, right? We want the simplest whole number ratio between the ions. So if we want to do this using the crisscross method, you take the magnitude of the charge of the positive ion, so it'll be a 1, and then the magnitude of the charge on the anion, which would be a 2, and then you swap those and use those as the subscripts for the opposite ion. So that's how you can also get, sulfur would be a 1, and then potassium would be a 2, and then if there's a 1, we leave the 1s off. Because if sulfur wasn't part of the compound, we wouldn't write sulfur there. All right, how about for aluminum? Oh, thank you, Siri, for giving me a sulfur general fact sheet. Aluminum and nitrogen. What's the symbol for aluminum? You can call me Al. And the symbol for nitrogen N. And what's the charge for aluminum? 3 plus. And the charge for nitrogen? 3 minus. So if we use the crisscross method for this, take the magnitude of each. So the magnitude of positive 3 is 3. And the magnitude, just to make sure I define that, magnitude means the number without the plus or minus. So 3 for aluminum, 3 for nitrogen, and if we swap those, they both end up with a 3, and we get Al3N3. But that's not the simplest ratio between the two, because we can divide both of those 3's by 3, and they could both be 1. So the correct answer would be AlN. So whether you need to use the crisscross method, like if you need to use the crisscross method, use the crisscross method. Just make sure you simplify everything. If you don't need the crisscross method, that's fine too. But the positive charges should add up to the same as the negative charges. Always. So for some compounds, there are common names, but chemists have developed systematic names for different types of compounds. Systematic names are a lot more useful because you don't just have to memorize things. So systematic meaning that there's a system that's used for naming the ions, or for naming the compounds. So the first thing you have to do is identify the compound type. And right now we're going to talk about ionic compounds. So ionic compounds almost always are going to be a metal and a nonmetal. And it could be a polyatomic ion or an oxyanion. So CO3 there is carbonate. It could also be, well, here we've got multiple ions. So this is calcium hydrogen phosphate. There's calcium, and there's a hydrogen, and there's a phosphate. They're not all named that easily, but again here, magnesium and then the oxyanion sulfate. Talk more about oxyanions, and I'll show you my strategy for memorizing those. So we can categorize these ionic compounds further and say that we've got ionic compounds that have a single charge, or as it says here, whose charge is invariant from one compound to another. So that means in every compound that it forms, it always has the same charge. That's the list that I have on Canvas. That's going to be, if we're looking at positive charges, right? So row 1A, or I mean column 1A, column 1B, scandium is always a 3 plus, and then aluminum, gallium, indium, zinc, cadmium, and silver are all also consistent charges. Aluminum, gallium, indium are 3 plus, zinc and cadmium are 2 plus, silver is 1 plus. So there's really only, 7 that you have to memorize outside of groups 1A and 2A. The second type, though, and all of the other metals on the periodic table fall into this category, can form different charges depending on which compound they're a part of. So you either have to be given what the charge is for that ion, or you have to figure it out from the formula. But we're going to start with the easier ones, metals that form one compound, or one cation. So these ones always have the same charges. We do kind of generalize more than this, that like beryllium is going to be 2 plus, and then gallium and indium 3 plus, and cadmium is a 2 plus. So most of them, again, group 1A, group 2A, predictable from their group number. And even group 3A, which has aluminum, gallium, and indium, you can use the group number to remember that. And then for all of these ions, because we're going to talk about some of the ions that form multiple charges have different names that they use. So it won't just be aluminum, but like iron could be either ferrous or ferric. So you're going to have to memorize a few of those at least. Oh, okay, so these are the ones that form more than one cation. We're going to talk about naming the other ones first. But Depending on the compound that they're in, they'll form more than one kind of cation. And then the names of these ions, names of the ions are the element names followed by the charge in Roman numerals. That's primarily what I want you to learn. Let's see, which ones do I actually think are worth learning? I'll put these together in a list, but I think especially iron, ferrous and ferric, and then the copper ones, cuprous or cupric. For the most part, these are being phased out because they follow an older convention, because they're not as clear as, for example, if we wanted to write out a compound and it was iron with a 2+ charge, it's clearer to write iron 2 than it is to write ferrous. Because with ferrous, then somebody has to know that ferrous means iron with the 2+ charge, whereas iron with a Roman numeral 2, it's just kind of direct, it's there, it's in the name. One pattern to notice with these is that the IC form is always the higher charge. So ferrous is going to be 2+, ferric is 3+. Whether or not they form a 2+ or 3+, or a 1+ or 2+, or 2 and 4, or mercury is a weird one. This top one is actually 1+, but there's 2 mercuries. And then lead being 2 and 4, right? So it takes like getting into Chem 2 where you start explaining that more. I want you to primarily know that you write the name with the charges in parentheses as the Roman numerals. And then just a few of these other ones. Definitely ferrous, ferric, cuprous, and cupric. But I need to talk to some of the other professors about which ones they include. So that when you go to Chem 2, if you take Chem 2, then you have those already memorized. Okay, we'll come back to these. In terms of remembering which ones form, or which ions form consistent charges, or only one type of charge, I use this pyramid, this triangle here, for remembering those, or staircase, as I like to think about it. So you can start with the 3A, and that you can remember because they're in 3A. So these are all 3+. I also remember this because aluminum, gallium, and indium, it's those 3 in the column that have 3+ charges. And then you move one space to the left and you get zinc and cadmium. There's 2 elements there, so they have 2+ charges, and silver has a 1+ charge. So any of these ions that form consistent charges or only one type of charge do not use Roman numerals in their name. So looking at the anions now, the monoatomic anions, so that's any single atom with a charge, and they're named by changing the ending of the element to IDE. So fluorine becomes fluoride, chlorine becomes chloride, so on down the list. Some of them will change differently. These ones, I think, is pretty consistent that the, okay, I think the one that's the least consistent about these, right? So fluorine, you go to the R and then you, or you could even say you go to the I and then you change everything after that to IDE. And so that's consistent, fluorine, chlorine, bromine, iodine. Oxygen, it's not oxygide. You cut off the G there, and so it's the, well, actually the Y too. So it's just the OX, and then you add the oxide. I'm sorry, I don't have any tricks for memorizing those. Just got to get used to them. For the first?
The first 5?
Yeah. For those 5, yeah. I don't have like an overarching, like, here's for all of them kind of thing. So the charges of those ions are also predictable from their group number, and it's basically their group number, 7A. 7 minus 8A gives you a 1 minus. 6A minus 8A gives you 2 minus, and then phosphorus, nitrogen. Is arsenic on there? No. Phosphorus and nitrogen. All right, 5A minus 8A is -3. And so there's another pattern there. -1, -2, -3. Okay, so naming binary ionic compounds. So this is just one cation, one anion, or one element in the anion. The name of the metal cation stays the same. And then you just take the base name of the anion, change it to IDE. There's no Roman numerals if there's, well, if the cation's one with a single charge. So that's one of the reasons it's important to memorize all those metal ions that do form only single charges. So for example, if we have potassium and chlorine forming this compound, ionic compound, we write potassium and then followed by the base name of the anion with chlor, and then we change the ending to IDE. And similarly, calcium and oxygen, we would just write the name of the cation, calcium, followed by the base name of the anion, which is OX, ox, and then change the ending to IDE, so calcium oxide. So how would you name this compound of silver and nitrogen? What's the first thing that you have to look for? Type of compound. So it's an ionic compound. Huh? Yeah, and then what would be next though? We need to check something else. Charges. Well, this one's, well, we're given a compound, so the charges should be balanced in theory. But does silver form more than one charge?
Yeah.
It does not. It just does 1+. So we don't have to worry about Roman numerals or saying like ferrous, ferric, that kind of thing. So we just write silver. And then the ending of nitrogen needs to change to IDE. So nitride. How'd you write what's the first step for writing a formula for rubidium sulfide?
Charges.
Charges? Symbols? What kind of compound is it? Ionic compound. How do you know it's an ionic compound? Yeah, rubidium's a metal way over yonder. And sulfur is a nonmetal, so metal, nonmetal. So rubidium is Rb. Sulfur, sulfide. So charge on rubidium? 1+, or I should just write the plus. And then sulfur? 2-. So how many of each do we need to make the charges balance? Rubidium 2, sulfur 1. RBs. Yes, we need more than one RB, so it's RBs. Okay. So the full names for compounds containing metals that form more than one kind of cation will have the following form, then the name of the cation, and then the charge of the cation in Roman numerals in parentheses, and then change the base name of the anion to IDE. So if you're given a formula and you're trying to write the name, you determine the charge on the metal based on how many, well, based on how it would balance out with the nonmetal. Because all the nonmetals form consistent charges. So those are never in question. Fluorine's always going to be 1-, oxygen's always going to be 2-. nitrogen is always going to be 3 minus. All right, so which two elements do we have here? Chromium and bromide, or bromine. Not changing anything yet, I'm just writing out the names of the elements. And I guess we know this is an ionic compound because chromium is a metal. Bromine's a nonmetal. Does chromium form more than one type of charge?
Yes.
Yeah, not part of the list of metals that form single charges. So bromine, what's the charge? I guess back up a step. How do we figure out the charge that this chromium has?
Based on bromine.
Yeah, based on the charge of bromine and the number of bromines. So we have 3 bromines, and each of those has a 1 minus charge. So, right, we got these 3 bromines, which means that we've got a total of a negative 3 charge. And that has to be balanced by the chromium. So what's the charge on chromium? 3 plus. So this will be chromium, and then parentheses, 3. And then the last thing we change is the ending of bromine to IDE. And then what did we have for, let's just show these. Okay. So if we were to use the older naming convention, this would be chromic bromide.
When we're doing assignments and stuff, is it fine if we were to do like the modern version chromium 3 bromide instead of the old-fashioned version? So you just want us to be aware of that, so if we see chromic, we're not.
Yeah, yeah. So I'll probably, like I said, I'll give you a list of the ones that I do want you to memorize, and there will be a question, at least on a quiz, maybe on an exam, that's like, what is the charge on chromium in chromic bromide? And so you need to know, okay, the chromic, which you should know, this is the way that I would do it, but I would remember that chromium can form a 2 plus and a 3 plus. And chromic is the higher charge, so chromic, it would be chromic bromide, so it would be the 3 plus charge. And then you remember OUS and IC is, IC is the higher charge. Yeah, okay, I'll do that in a second. Yeah. So for this one, right, again, I know that like right here at the top right, it says naming ionic compounds containing a metal that forms more than one type of cation, but you should be practicing sort of these checks because in the questions that I gave you on here, the extra practice, like the last section is just name the following ionic compounds. Each of the sections kind of tells you like, these are single charges, these are multiple charges, these are polyatomic anions. And then the last one is like free for all. But you should kind of be doing those mental checks, like, is this an ionic compound or molecular compound? So look at iron sulfide. We have a metal and a non-metal. Okay, so it's ionic, and then we say, does iron form more than one type of charge? Yes, because it's not one of our ions that doesn't do that. Also, if you're aware of ferrous versus ferric. And then you say, okay, what's the charge on iron here?
2 plus.
Should be a 2 plus because sulfur forms a 2 minus charge. Like I said, the nonmetals always form consistent charges. So this will be iron, 2, sulfide. Or it would be ferrous sulfide. So the question was asked, like, what would this compound look like if iron instead had a 3 plus charge? So we'd know that it would be iron with the 3 plus charge because the formula would be different. But we say, let's actually go this way. So we've got iron 3 sulfide, and we wanted to write the formula from that compound name, we know that we have iron, and we know that we have sulfur, and we know the charge on iron is 3+, sulfur is 2-. Yeah, and this is where the crisscross method is especially helpful because you get two numbers that don't go evenly into each other, right? When it's like one thing has a 1+ charge, the other has a 2- charge, then, oh, I need two of them. Makes that very easy. But these, we have to use the least common multiple of their charges. So this will be Fe2S3. What would the other name for iron 3 sulfide be? Ferric. Did I think I don't know if I erased something. Yeah, I did. Ferric sulfide's day off. I guess Ferris Bueller's day off, but it's like iron 3+, or iron 2+.
Ferric Bueller's day off.
Write the formula for ruthenium 4 oxide. So again, ionic compound because ruthenium is a metal. Ru. I wonder if ruthenium was named after somebody's daughter or wife, Ruth. So ruthenium is Ru. Oxide, O. And then what's the charge on ruthenium? 4+. And then on oxygen, oxide? 2-. So how do we balance those charges? What's that? RuO2. I feel like there's another pun there somewhere, but I don't know what it is. He had like... Anyways. A lot of intrusive thoughts tonight, sorry. Okay. So those are, ions forming multiple charges. Polyatomic ions. Polyatomic ions are a whole heap of fun. There's a lot of them, especially oxyanions. So you're going to see a lot of these compounds, especially like nitrates, a lot of nitrates. If you take Chem 2, you'll be dealing with these a lot. Nitrates, sulfates, carbonates. So any ion that's composed of 2 or more atoms is called a polyatomic ion. So these are ions formed of many ions, or many atoms. Right? Poly meaning many, atomic meaning atoms. And then there's a specific subset of these that are the oxyanions. For some of the polyatomic ions, you kind of just have to memorize them. I'll show you some methods for remembering the oxyanions. Actually, let's see. Okay, we'll do it with the oxyanions, good. So if you're naming an ionic compound that has a polyatomic ion, you're going to name it the same way, except instead of changing the anion's last sort of syllable to IDE, we just leave it as whatever the name of the polyatomic anion is. So sodium nitrite, we have sodium, Na+, we have nitrite, which is NO2-. So NaNO2 is sodium nitrite. So here's a list of some common polyatomic ions. There are some of these on the list that I put up on Canvas. It's the same Chem 20 list. The ones that you, out of this list at least, that you do need to memorize are acetate, or hydroxide, chromate, dichromate. These ones like hydrogen, so there's like hydrogen carbonate. It's also sometimes called bicarbonate. The hydrogen carbonate is a little bit more descriptive because it's a hydrogen and a carbonate. Similarly, you can have hydrogen phosphate, which is phosphate with one hydrogen, and dihydrogen phosphate is just phosphate with two hydrogens. Ammonium's that positively charged ion. Permanganate you have to memorize. Cyanide and peroxide. The rest of these I'll show you methods for remembering them because they're oxyanions.
So the ones highlighted are the ones we have to memorize.
And some of these are on that list that's on Canvas. I think the only one, no, I think I have all of these ones on there that I've highlighted.
Yeah, you posted.
There's that one, but there's also another one, I think it says like polyatomic ion study, or polyatomic ion quiz study guide.
Yeah.
Yeah, at the bottom of the chapter 4 module. I believe all of these are in there. So most of the polyatomic ions are oxyanions, which are just a specific class of anions that all contain oxygen. So when a series of oxyanions contains different number of oxygen, they're named according to the number of oxygen atoms in the ion. So if there are two ions in the series, the one with more oxygen atoms has the ending ATE, and the one with fewer has the ending ITE. And I'm going to show you my method for memorizing these in a second. Yeah, so this is just from the book that if you have, all right, well, this is how I do it. These are the base forms. ATE is your base form. You memorize the ATEs. And then if you have one more oxygen than the ATE, it's perchlorate. If you have one fewer oxygen than the ATE, the ending changes to ITE. So here would be chlorite. And then if you have two fewer than that base form, it's hypochlorite. You just add a prefix. And do you want to note that all of these just have the same charge? So the charge doesn't change, which is really convenient for memorizing them. Dr. K's tricks. So you can memorize the ATEs, again, like I was saying, memorize them, and then memorize this pattern. Wait, how is this upside down? How is it shown in the text? Anyways, yeah, chlorite is the light version, like Bud Light. Perchlorate, like hyper. It's also used a lot in just like medical terminology. So if you've watched any significant amount of like House or something, these kind of come up a lot. So per meaning more is like hyper, hypo meaning less. Like a hypodermic needle is like a subdermic needle. Hypo meaning below, dermic meaning skin, so below skin. Yeah. So here's, all right, now we're going to get into it. Okay, so if we've got a periodic table up here, and I'm going to draw just like a section of the periodic table. Okay, so starting with this is phosphorus, sulfur, arsenic, and selenium. Okay. So these four elements all form oxyanions, and they all form oxyanions with an ATE form that has 4 oxygens. So this will be, if this is the base form, this is going to be PO4, this will be ASO4, this is SeO4, this is SO4. And those will be phosphate, sulfate, arsenate, selenate. 4 of them in this box, 4 oxygens each. Different color here. We're going to do, this is chlorine, this is bromine, this is iodine. All right, so chlorine, bromine, iodine. This group of 3, how many oxygens does each of those ATE forms have? 3. So this is ClO3, BrO3, IO3. Chlorate, bromate, iodate. And the best part about this is, what charge does chlorine form? 1 minus. What charge does chlorate form? Also a 1 minus. So chlorate, bromate, iodate, 1 minus. What charge does sulfur form? 2 minus. What charge does sulfate form? Also 2 minus. Sulfates, oh, I gotta go back to the black. Sulfate's 2 minus, and selenium is also 2 minus. So selenate, and again, remember the charges, when you change the number of oxygen, charge doesn't change. So selenate, perselenate, selenite, hyposelenite, all gonna be 2 minus. So what do you think phosphorus, phosphate, and arsenate, what do you think their charges are? 3 minus. They said it couldn't be done. The whole periodic table is made out of patterns. All right, I got one more for you.
Oh, the pumpkin. No way, there's more.
But wait, now this one is a little bit different. And not because that line is all squiggly. Right, so what elements are these? Boron, carbon, nitrogen. Now, these ones, they buck the trend a little bit. But again, it's another group of 3, so how many oxygens? 3. So this is borate, carbonate, nitrate. That's not nitrate. That's nitrate. Okay. Now, the trend that gets bucked here is the charges. So instead of having the same charge as like the group number that they're in, or what their element would normally form, nitrate is a 1 minus, carbonate's a 2 minus, borate's a 3 minus. So it goes 1, 2, 3. There's still a pattern. Oh, and I should have done these in a different color. Do that real quick. Okay, so now the only thing that you need to, you need to memorize these patterns, you need to learn where these patterns are on the periodic table, and that does take a little bit of work. But remember, group of 4, 4 oxygens, group of 3, 3 oxygens, group of 3, 3 oxygens. And those are all ATE. And then these, chlorate, sulfate, phosphate, and everything below them all have the same charge as their group, or as their element would form by itself. The only thing that changes is nitrate, carbonate, and borate are 1 minus, 2 minus, 3 minus. So if I wanted to write phosphite, right? ITE means 1 less oxygen. So PO3, still 3 minus. If I wanted hypophosphite, hypo, take off another oxygen, 3 minus. Hypo, yeah. Oops. So yeah, and then we could go the base form, which would be PO4, which is phosphate, still 3 minus, and then perphosphate be PO5, 3 minus. So that's 10 things that you memorize, or 10 things that you memorize the groups for. Then you memorize 3 rules, and you've memorized 40 different compounds. It's the power of like patterns, first of all, but like if you can figure out these patterns, if you can figure out an underlying theory, then it does way more than just memorizing stuff. Okay.
Why they form those charges? Or is that too complicated for right now?
I don't even know if I know specifically why those formed those charges.
Probably.
Yeah. I can later I can explain if you want to know why like zinc, cadmium, and silver form those charges that they do using electron orbital diagrams, but later. All right, naming these things now. So if we want to name the compound that has tin and this polyatomic anion, so the first one's tin. What polyatomic anion is that? What's the name of that? Chlorate. It's got 3 oxygens, Chlorine's here. It's in the group of 3 oxygens, the ATE form, chlorate. What charge does chlorate have? 1 minus. And we have 2 chlorates. So what is the charge on tin? 2. Does tin form more than one type of charge? It does indeed. I don't know why I wrote this with a capital T. Tin, and so that'll be tin, 2, chlorate. Or stannous chlorate. Tin is 2 plus and 4 plus. So would the formula be for cobalt 2 phosphate? Cobalt? Yeah, what is phosphate? PO4. What's the charge on phosphate? 3 minus. Again, crisscross rule. CO3, and then for these polyatomic ions, we need parentheses. And then the 2 is outside the parentheses. All right, the last thing we're going to learn how to name today. Next week we'll do more naming stuff. But the hydrates are ionic compounds that contain a specific number of water molecules that are associated with a formula unit. So the formula for Epsom salts is magnesium sulfate with 7 waters, or heptahydrate. And its systematic name would be magnesium sulfate heptahydrate. So hepta being the prefix for 7, so 7 waters. And then cobalt chloride, so it'd be cobalt 2 chloride hexahydrate. And these things look different. So like the cobalt chloride hexahydrate is this like bright red, pinkish color. And then the anhydrous version is a much duller, not even really a dull, but more of a purple. Yeah. These are probably colors that I'm slightly colorblind, so these are probably ones that are not great.
One's very pink, one's very purple.
Yes.
Because you don't have 2 extra colors.
So these are the common hydrate prefixes. So it's all based on the formula unit. So if there's not at least 1 water per formula unit, this is not like it's not like other compounds where we have to have whole numbers, because it's a formula unit. We're talking about like a lattice of these things. There could just be half as many waters as there are formula units of the ionic compound, which is a little bit weird, but that's reality. So what would this first compound be named?
Calcium sulfate hemicide.
The hemihydrate's got a lot more horsepower than the regular hydrate. Yeah?
If it doesn't have water associated with it, then do we put anhydrous after? Or do we just not?
I think that's interesting, because I think on a like reagent bottle of something, it would say anhydrous. But I think for the systematic name, you just wouldn't write the waters. Because if the waters aren't there, then you don't write them in. But if you're like looking for a chemical on a shelf, there's going to be versions that have hydrates, and they'll have the number of waters that are listed on them and probably the name. But if it doesn't, those will say anhydrous. Yeah, for clarifying purposes, and because it's hard to keep things that dry.
Right.
So you want to be extra careful to not leave it open, because there's water in the air, and they'll start absorbing it. So what would the second compound be?
Barium chloride hexahydrates.
Barium chloride hexahydrate. And then in the formulas, this isn't just like a weird thing that I decided to put in here. The dot is part of it. The dot shows that it is a hydrate and that those two are related. So for this formula of copper 2 sulfate, we have copper. The copper has a 2+ charge. What does the sulfate have? SO4 is a 2-. This is a copper 2+. So this will be SO4. And then the dot. Penta is 5, so 5 H2O. Neat. All right, and that's it for today.